All right. Sorry about that. The My streaming for whatever wouldn't work. I think the key reset, but that's fine. Um, so up on the screen, I have right now a number 24, and earlier I had number 23. Um, so I'm gonna give people a couple minutes to like look at this. Um, I'll scroll down again here in a second, and then we'll go over 25 together. But as you have questions on number 23 or 24, put them in the chat and I will go over them. All right, so take a couple minutes just to check your work, and then I'll take questions. All right, so any questions on 23 or 24? So when dealing with the matrices, we don't multiply x, y, and z. Uh, I'm not sure about your question. Right now, all we're doing is okay. So there's the elimination part. That's all in navy blue. Okay, that's that's separate from the determinant. In the determinant, the first thing we have to do is get a coefficient matrix. All right, and that's in red. All right, the coefficient matrix is just the matrix of coefficients of x, y, and z. All right, so here we have -4, -2, and 5, -4, -2, and 5, -2, +4, -2, -2, +4, -2. All right, that's how you get your coefficient matrix. And those are just numbers. They kind of have something to do with x, y, and z, but right now those are just numbers. All right. Um, and then you do the diagonals. All right, and that's all of this work right here. And all of that work will get you a number. In this case, that's +58. I had to go over the line because I was running out of room. Okay, I'm going to just address this homework question real quick. You have to submit stuff to on campus. Right? I made a mistake in saying there was only one thing that you could submit. In the future, I'm going to change that. For instance, for tonight. Yes, you have to submit it to on campus. If I don't see a submission on campus, I'm not going to count the grade, even if you emailed it to me. Okay, because I don't want to go searching through emails, especially now when I'm getting emails every like 10 minutes. All right. You have to submit it to on campus, so I have it in one place. Today is kind of an exception to that. That's okay. But I still want a submission or I'm not going to count it. All right. Any other questions on 23 or 24? All right. Since there are no questions on 23 or 24, I would like to do 25 together. or at least in front of you, so you can see all of the work that's needed in order to get full credit for something like this. All right. So number 25, this is the problem. I think originally there is no 0r here. It's just it's negative s minus 4t is equal to negative 9. Okay. You have to make sure, in order to do this right, to add that 0r so there's a placeholder. Okay, so that 0r has to be there. And we're going to solve this using elimination. So I'm going to choose to eliminate s. Okay, you can eliminate r, you can eliminate t. That's okay. Right now I'm going to choose to eliminate s. All right, so in order to do that, I noticed that the second equation and the third equation have the same sign and the same coefficient. So I'm going to pick both of those to eliminate s. All right, and to eliminate s, all we have to do is add down. So negative 2r plus 3r, that's just r. These s's cancel. And then 5t plus 5t is 10t. And 27 plus 0 is 27. So we took the second and third equation, we eliminated s, and now we have a equation of just two variables. All right, I'm going to do the same thing for two different equations, or at least a different combination of questions, a different combination of equations. All right, so I'm going to pick this first one and this second one. Okay, and we still need to have the same coefficient for both the s's. So because we picked s here to eliminate, we also have to pick s here to eliminate. And in order to do that, we have to multiply this top equation by 2. So when we do that, we still have 0r minus 2s minus 8t is equal to 18. And then the bottom one we can just leave alone. And when we add down, we get 3r plus 3t minus 3t is equal to 18. Okay, and now we have a system of two equations. We have r plus 10t is equal to 27, and we have 3r minus 3t is equal to 18. And then we have to solve this system of two. Okay, and you can do that in a lot of different ways. You can use elimination, you can use substitution, you can use graphing. It doesn't matter, but you have to be able to use one. All right. I'm going to use elimination here just so you guys can actually see what I'm doing. I'm going to multiply this top one by negative 3, and I'm going to cancel these r's. When we do that, we get negative 3r minus 30t is equal to 71, negative 71. Negative 81. And then I'm going to leave the bottom one alone. And then again we add down, cancel the r's. So we get negative 33t and then negative 18 plus, negative 81 plus 18. And we did something just a little bit wrong here. me 1 second. The green one looks fine. Yeah, it looks like the red one's fine too. Oh, I see. Okay. This should be -9 up here, which means this is -18. And this is -18. All right. So this should be negative. All right. And then when that happens, this is -18, which means this down here is -99. So t is equal to 3. Okay, now we solved 1 for one variable, and we can use this t in one of these two equations. So I'm just going to pick the second one. All right, so 3r minus 3 times what t is, which is 3, is equal to 18. So 3r minus 9 so r is equal to 9. Okay, any questions about what I have up on the screen so far? All right, after we get two variables, we can plug both those variables into one of our originals. Except I think we still did something wrong here. Yeah, that's what we're supposed to get. So we're supposed to get r is equal to -3, and I'm trying to figure out where I went wrong. T is definitely 3. We did that part right. Oh, okay. This is back from the original. These should be negative. All right, so 3r minus 9 is equal to -18, not +18. So 3r is equal to -9. So r is equal to -3. So you're right. I just screwed up the work a little bit. All right, and then we can plug in both of these variables into one of our original 3, and then we're done. So I'm going to pick that second one. 13 times 3. I'm not exactly sure where you're asking. But we can let's keep going. This is still all the right work, and it seems like you guys are getting it. I just want to make sure everyone understands the work that I'm expecting. All right. So then once we plug in both of these, we can solve for s. Okay, so then we have 6 minus 2s plus 15 is equal to 27. So negative 2s plus 21 is equal to 27. Negative 2s is equal to 6. So s is equal to negative 3. Okay, so that was messy, but we got there. Again, this is kind of the work that I would expect. And yeah, it's really easy to mess up, but that's why you got to be very, very careful. Okay, so that's the first part of the problem. Is there any questions on this elimination part? Are there any questions over this elimination part? All right. So that's the first part. No, well, for the elimination part, yes, this is all that there will be on the test. You'll have to solve a system of 3 equations using this concept. All right. So this is one thing I'll expect you to do on the test, and that's one part of the homework. Now the other part is to find the determinant of the coefficient matrix. All right. So I'm gonna copy and paste our original problem. So our original problem is this. The first thing you need to do is you need to get a coefficient matrix from this system of 3 equations. All right. All that is are all the coefficients of r, s, and t, which is 0, -1, -4, -2, -2, and 5, 3, 2, and 5. Okay, then we have to find the determinant of this. And the first thing you do to find the determinant is you repeat the first 2 columns. And then take the diagonals and multiply them together. All right. So 0 times -2 times 5 plus -1 times 5 times 3 plus -4 times -2 times 2. And then we subtract the opposite direction. So 3 times -2 times -4 plus 2 times 5 times 0 plus 5 times -2 times -1. How are you going to do tests? Tests are still for discussion. I'm still trying to figure that out. But I would plan on one late next week or early the week after. Okay, so then we take whatever number this is and subtract whatever number this is. So that top part, if we simplify it, is 1. That bottom part, when we simplify it, is 34. So 1 minus 34 is negative 33. That's okay. I'll give you points. You're good. This is also going to be available after, and then you can also watch the period 6 one if you need to. That's up right now. Okay, so that is elimination. That's solving a system of 3 equations using elimination, and then taking the determinant of a coefficient matrix. Are there any questions over any of that? Okay. So since there doesn't seem to be any questions, the next thing we need to do is to kind of put all this stuff together. And we do that with Cramer's rule. Okay, so I'll give you a minute to kind of write this down, and I'll explain it. And I'm going to erase some things so it's not as confusing. All right, so this is Cramer's rule. If you had me last year, you probably have seen this before. But this is kind of doing elimination just in a lot different of a way. All right. So as you're writing this down, I'm just going to kind of talk through it. If we have a system of 3 equations, a system of 2 equations, or more, all right, so you can have 4 equations of 4 variables, 5 equations of 5 variables, as far up as what you want. If you have that, the first thing you need to do is to get a coefficient matrix. So you need the coefficients of x, y, z, a, b, c, whatever, and put them in a matrix. Then you need to find the determinant of that coefficient matrix, kind of like what we just did on the last problem. All right, so system of 3 equations, get a coefficient matrix, take the determinant of that matrix. I'll give people just a little bit of time to write down. Okay, and then once you get the determinant of that coefficient matrix, you can use that and other matrices to solve for x, y, and z. All right, so for x, well, first, all right, this determinant, the determinant of our coefficient matrix, that is the denominator of x, y, and z. Okay, so that comes out to be a number. That number is the denominator of x, y, and z. Okay, so right here, and right here. All right, the numerator is the determinant of a different matrix. Okay, so for x, that new matrix is the coefficient matrix, but instead of in the x column, the x coefficients, we have the answer column. All right, so each column represents a different variable. All right, so this blue column represents the x variable, this y column represents the y variable, and this green column represents the z variable. And it's the same for every matrix. Okay. And the numerator is the coefficient matrix with everything the same except the column that you're trying to solve for. Okay, so for this x, we're trying to solve for x. So we replace the x column with our answer column. Okay, for the y, so for solving for y, we replace our y column, our middle column, with the answer column. Solving for z, we replace our z column with our answer column. Okay, and then we take the determinant of all those matrices, right? So whatever the determinant is for the numerator in x, you divide that by the determinant of our coefficient matrix, and you get what x actually is. Okay, so this is just another way to solve. I realize that's probably a lot of writing. We're going to do an example, but before we do that, are there any questions about what's up on the screen? All right, so for example, say we have this system of 3 variables and 3 equations. The first thing we have to do with this is we have to make a coefficient matrix. So that coefficient matrix, I'll try and do this color-coded. The x column, or in this case the a column, is -6, +1, and -2. Our b column is -4, +5, and +4. And then our c column is 1, -5, and 4. And then we have our answers. Okay, the first thing we need to do, or the second thing we need to do, is take the determinant of this matrix. And we do that again by copying down the first 2 columns and then doing what we did on the homework, all right? Okay, so this is that determinant. And then we get a number for that. And that number is our denominator for our a, b, and c variables. So I'm going to take a second just to do that. Okay, so I got negative 10 for this. I feel like that's wrong, but I did this early and I got negative 250. Ah, okay. Should be a plus. Okay, so negative 10 plus 120. It's 110. So this is a plus 94. That's where I went wrong. And then this still is negative 250. Okay. So that's the determinant of our coefficient matrix. Okay, and that is the denominator for A, B, and C. Okay, and then our numerator is the determinant of a different matrix. So for A, our matrix is the coefficient matrix, except our A column is going to be replaced with our answer column. And then everything else is the same. Okay, for B, our matrix is the coefficient matrix, except for in our B column, our red is replaced with our answers. And everything else is the same. And then for C, it's the same thing. We're solving for C, so our C column is replaced with our answers. And everything else is the same. Okay, now, you could take all of these by hand for the numerators. I'm not going to expect you to do that. What I would expect you to do is to get on a calculator and take the determinant that way. Okay, so you'd go to your second matrix, you would edit a 3 by 3 matrix, put those numbers in, and then go to second matrix again, scroll over to math. And what we want is DET, which is that first option in that menu. And then recall the matrix that you edited. Okay. All right. So this is a lot, but this is the work that I would expect. Okay. So I think for answers here, let me see. Should get 0, -1, and -3. So that means the determinant of this numerator is 0. So then A is equal to 0 divided by -250, which is just 0. For B, our determinant ends up being positive 250. So 250 divided by positive or negative 250 is just negative 1. And then for C, our determinant ends up being positive 750. And positive 750 divided by negative 250 is negative 3. All right, so here's what I'm going to expect on the homework and on a test. All right, everything from here up is going to be by hand. So you need to find a coefficient matrix and take the determinant of it by hand. Then, below the line, you need to set up equations for A, B, and C, or X, Y, and Z, and then get actual numbers for the fraction and actually solve like this. Okay, no, there is no elimination. You are doing elimination, you're just doing it in a slightly different way using matrices. Okay, but this is kind of how your calculator works doing it. All right, so I realize this is a lot, and I'm gonna highlight it and make it a little bit smaller so you can all see it on one screen. Okay, but this is all the work. This would be one problem. Okay, you need to find a coefficient matrix, take the determinant of that coefficient matrix, and then set up equations for A, B, and C, and then solve for that. Okay, that's a lot. Are there any questions about anything you see on your screen? All right, your homework is on that same worksheet that you did before, except it's numbers 18 and 19. And I want you to do those using Kramer's rule. Okay, so you have to solve those system of three equations using Kramer's rule, like what you see on the screen. Okay, so I'm going to leave this open for the next like 30 to 40 seconds. If you have any questions, please ask, at least broad questions. If you have any specific questions, I'm going to hop over to Teams in the next 2 or 3 minutes. I'll start a meeting, and if you want me to help you work out a problem, I can absolutely do that. Okay. How many of these will be on the test, and about how many points will they be worth? Okay. So here's kind of how the test would break down. Your test will be, you have to solve a system of two equations using any way you want, so long as I can see your work. You will have to solve a system of three equations using elimination. You have to solve a system of three equations using Kramer's rule. And then you will have to do matrix operations. Okay, so adding two matrices together, multiplying by a scalar, and then multiplying two matrices together. And it might be a combination of those, like that all might be one problem, but all those things would be involved. All right. Kramer's rule would probably be worth the most points because that shows me that you know how to take a determinant, you know how to solve a system of three equations using Kramer's rule, and there's a lot of like different parts involved. I have a practice test somewhere and a graded practice test somewhere. I just need to find it, and that kind of has point values. But if this is a 50-point test, my guess is that Kramer's rule would probably be worth about 12 points. 12 to 15. It would be a good chunk. Okay, but it's really just finding determinants, and then the rest is setting up what A, B, and C look like up on your screen. So it is a lot. It is a lot of steps, but it shows me that you know how to do a lot of different things and that you can set up an equation. All right, so I will leave this up for the next minute or so. Again, any general questions I can answer, go ahead and ask them and I'll answer. Otherwise, in the next 2 or 3 minutes, I'll be in meetings or I'll be in Teams to start a meeting. All right, so I will end this and then I'll start a meeting in Teams in the next like 30 seconds.